Okay, I'm back. And I went ahead and just go and labeled the volcanic trend line, and it does have like an internal segment and then a more external one. So here's Loci, Mauna Loa, Lohi, Lohi, Mauna Loa, Hualale, Keho, Olawi, Lanai, and West Molokai. And then the other one, the Kia, that was the Loa trend. The Kea trend is Kilauea, Mauna Kea, Kohala, Kohala, Haleakala, which connects over 5 to 5 here, and then West Maui, which is just through here. I'm not sure why these are not considered to be part of the trend. I wonder what this would look like exactly on a sphere. Maybe if I look at this. Mauna Loa. Kilauea. Mauna Loa, Kilauea. I just didn't draw enough of them. I didn't write enough of them. Let's use that as a good reference. Okay, because it basically seems like if we were to zip up this here, zip this up, and then create a sphere out of it all. That's this is kind of circular, and this is kind of a larger, like, surrounding circle that maybe has a general inlet from somewhere. Like, this is a backstop masses. Mostly, like, maybe there's currents that broke through the masses to make them more like traditionally volcanic, but they behave more as like a backstop. Maybe. Where the current generally came in maybe from a point. Like a focused inlet. Like it had a main inlet conduit channel. Maybe it was around here. I don't know. Or just 15. But then it flowed like this way. Essentially, at this point, it's so hard to visualize because I'm still visualizing it in like it's pretty much flat, but it's significantly warped. Like, in order for this to be a sphere, this here has to be pretty much here connected to top, like zipped up. The 15s together, opposite lifted from a point wherever that is exactly, and probably some degree of this like overlapping into somehow, or just some like extension from maybe the current maybe the current was flowing in this way, but then as it extended it flowed more this way, and I don't know. Okay, so that's... It doesn't, like, not trend with the sphere, so that's good that there is this... The trends of the... I guess let me post this. This is my last video. Post. Trending, speaking of. Jones Dwight Dana proposed that the alignment of the Hawaiian Islands reflected localized volcanic activity along a major fissure zone. Great fissure theory until mid-20th century. Originally considered Kilauea a flank vent of Mauna Loa, Kohala as part of Mauna Kea. So I found that interesting. That's the... Mauna... Or, which ones? Kilauea as a flank of Mauna Loa. That's interesting. It almost makes me think, like, on the larger particle sphere, that this was like a proton, and then it had a neutron, like, backstop that was Kilauea that provided, like, a specific backstop. Like, if a current comes through here, then, like, this is this backstop. Like, this has maybe this backstop. This has maybe this backstop, and then this has this backstop, or no, this here, this here, this here, this here, and here. Maybe this one might have multiple backstops, kind of thing. And then outlet, where maybe this was... had a current flowing through here from this way that then wrapped back around, like it kind of had an inlet generally, but then it spirals so that this region maybe had some cross currents. That maybe passed up and went up into here and cut across here, basically, and started to, like, physically sever the top half. Maybe. Like, past the inlet. It basically goes past the inlet current. And if that's the case, like an inlet current coming this way generally. Like, past it, up into the half that it's not spiraling in as much, because maybe when it passed it, it really initially produced a pole as like an actual backstop to encourage energy this way as well. Oh yeah. Here's something I found interesting. No evidence of 60-degree plate change to adjacent plates. So, like, if we're gonna say that the Hawaiian island chain here bends abruptly because of the, like, bend in the flow of the Pacific plate, that no other adjacent plates, like, show evidence of this, is strongly supportive that it is because a particle rolled on top of the plate and the plate didn't actually have that effect going on. I know that sounds ridiculous. It provides further support of the concept, that's all. Maybe not, it, like, makes it, like, the most likely thing. Louisville chain, Gilbert Ridge, Tuvalu chain. I just search for like a bunch of things. Images. That's not images. What have I done? Okay. I guess that might be the best one I can find right now. Hello? Probably getting hacked. Fuck. Uh, the amounts of volcanism versus the age, or the amount of magma meters cubed per second versus the age of a volcano is much higher meters cubed per second approaching present time. So like when it was if it was a sphere and it was breaking apart, like, it would make sense that like the majority of the magma would be stored in just like the final components at the nucleus rather than like the outer shell region. If like the Hawaiian island chain is a depositing of a rolling sphere components. So the reason I found that here, this one might actually be pretty solid. Like, there's certainly a relationship to whatever's going on here. Here's the actual image that I saw. Hawaiian Emperor chain, and then it kind of continues down to the Gilbert Ridge and Tuvalu chain here. Which is certainly not exactly there if it's talking about this, although, let's see. Here's Fiji. So it's leading into Fiji and then passing through that region. Over here, I guess. This one. Which goes out. Here's that dragon thing. It's pretty far out, like, relative to here. So it does look like it's this. Is it this? I don't think it's that one. That's Rudo. Rudo here, I guess. Something around here. Samoan chain is just above here. Wonder if there's any islands. That's crazy. What the? They're so, like, particulate. What? Whoa, a figure 8? So, in the past, I talked about in this video playlist. I'll just start referencing my previous videos if I can think of them. Photo electric effect. This one. Generally talking an island hopping. These ones probably about how it's sort of like there's a current flowing this way, where there's almost like particles that are empty polygons that bounce off of this mass and go this way and get filled with material, like they extract material. Like they come in like physically just boundaries of a polygon without the innards filled really, because they're just like bubbles pretty much, relatively speaking, that then when they collide with this region, they physically extract material from the land masses and maybe even become part of it. But it looks like they might also just go right through the region. That looks like it was there. The way it has like this two separations in the segment. I don't see this exactly. If this was here, then this was generally like over here. This here is pretty straight in line with Fiji. It's too in line with Fiji to be unrelated. I don't know what to make of it. Maybe a particle formed here and then broke away as like it was more here, and then it just physically spread, like there was a current coming this way and then a current this way from here. Here's Papua New Guinea. There's a current coming pretty much maybe to the boundary here, it looks like. Like there's one that bends around here, but it looks like it might actually bend even more here. It's like its maximum boundary, like right before the particle, which is then at Fiji. So like coming in this way, and then there's a second current coming in like from the collisions, making like a boundary where the current's flowing downward. Like it's hitting this, a boundary of a current coming out this way that's producing just a general boundary, but then it's flowing down the boundary. And Australia, I mean, I really want to say it physically somehow moved above, like jumped things that were being deposited along its boundary somehow. That would be so cool. But maybe it was there and there, so like this would be, let's see how far. Can't measure on Google Maps. Okay. Let's say 1,700 kilometers. Okay. And then measure here. 1,700 is around here. So around there would be about where this particle would be if, like, Australia, this whole chunk, like, slid away. So let's look at this. So it would really have been forming here, like here. I don't know. I don't know. Like maybe it was generally like the whole process, but then like the final one was generally here, and it's not part of Australia because it's over here still. And it occurred on like the mantle side, whereas this occurred on the continental underlayer side of like what actually is being shaped. Even though they're like directly adjacent, maybe it physically was moved away so that like this was really here, and then this generally reaching out to something similar to over here, maybe. It's so hard to reason through this, oh my god. uh, that does seem plausible to be related. Maybe I can take an image of it. Just take an image. Throw it on here for now. Scroll over here, don't change the size. Take another image. They're not the worst sizes. They're not the worst fits. Let's say maybe I can turn this one a little bit to be more in line. And then maybe make it a little opacity. Make this one full, and then this one top it, and this one opaque, see through. Let's look at it. It's a little hard to see it. Like, I don't know. It almost is not at the right angle, maybe. If it is actually related. Like, I seem to not have it yet at the right angle. Da-da-da. It doesn't have to be identical, but it would be real cool if it was quite identical. If it was quite identical. Like maybe this here, here is a reference point. Like that. Maybe. It's out in the open, so it's almost like a subsequent bond that broke. Do I still have one of those? I feel like I just saw one as I scrolled out. That was weird. Okay. Hawaiian swell, the gravitational anomaly. And flexure, as in like something rolled atop it. The Hawaiian Emperor seamount chain in the Pacific Ocean has provided fundamental insights. This is from Watts et al. Why can't I? What the fuck? So I need to zoom to there. What's it all? JGR, solid earth. Okay, yeah. Provided fundamental insights into hotspot generated intraplate volcanism and the long-term strength of oceanic lithosphere. However, only a few seismic experiments to determine crustal and upper mantle structure have been carried out on the Hawaiian Ridge. Probably because it's so anomalous that no one wants to like bother with it. The more we investigate, the more it doesn't make any sense, and then I get like segregated from the community. They don't want to ostracize because I'm like confused by Hawaii, and this like our model can't explain it very well. So anyone researching it just doesn't get funding. Maybe, maybe something of that nature when it comes to this. Just relatively speaking, like less likely, not like absolutely speaking. Okay. No deep imaging has ever been carried out along the Emperor Seamounts. We present the results of an active source seismic experiment using 29 ocean bottom seismometers carried out along a strike profile of the seamounts in the region of Jimu and Swako. Suiko? Goyets? Joint reflection and refraction tomography inversion of the OBS data show the upper crust is highly heterogeneous, with P wave velocities, which are attributed to extrusive lavas and clastics, greater or less than 4 to 5 kilometers per second. In contrast, the lower crust is remarkably homogeneous, which we attribute to oceanic crust and mafic intrusions. Moho is identified by a strong PMP arrival at offsets of 20 to 80 kilometers, yielding depths of 13 to 16 kilometers. The underlying mantle is generally homogeneous, with velocities in the range of 8 kilometers per second. The crust, 7 to 9 to 8. The crust and mantle velocity structure has been verified by gravity modeling. While top of oceanic crust prior to volcano loading is not recognized as a seismic or gravity discontinuity, flexural modeling reveals a 5 to 5.5 kilometer thick pre-existing oceanic crust that is overlain by an 8 kilometer thick volcanic edifice. Unlike at the Hawaiian Ridge, we find no evidence of magmatic underplating. So this is more focused on just the Emperor chain, I guess. Pressure pushing down from a ball rolling through, maybe. Oh my god. Causing an actual, like, divot by, like, focused pressure. Wide-angle seismic reflection examples and refraction data record sections with observed and predicted travel times based on the velocity model in Figure 4. Free air gravity anomaly. There's a lot of things that are probably of interest here. Ooh, depth. It really is like it has roots down to and like chakra points, like a surface roughness, an eyeball of a snake-like feature, the W, and then like a gap region where maybe like by the pressure it caused like an upwelling of mantle between the like rolling balls openings to fill the space with a different material that like creates changes in the way seismography appears. I mean, it really does have that appearance of like a downward, but like connected up here, all connected, but with downward propagating energies. Like it doesn't really have more of like a pyramid from within thing going on. I don't know what I'm looking at exactly. Let's see. C, RMS, and velocity uncertainty from the 100 model realizations. Observed seismic calculated flexed moho. Evidence of intrusive bodies within the main edifice. I'll have to look at this more closely. Again, it looks like depositing from above rather than from below. I know it looks like from below as well, but it's plausible from above. Load and flexure, gravity anomaly. Okay. Whatever's going on here looks pretty. Seismic refraction, and let's go to the conclusions. Gravity data have revealed the P-wave velocity and density structure of oceanic crust along a 400-kilometer long profile with the crest of Sueco and Jimu Goyets in the Emperor Seamount chain. The crustal thickness is 12.1 plus or minus 1.5 kilometers, and the moho depth below sea level is a little deeper. So it's practically rolling on a still molten, like, basalt magma, mantle magma, basic, that then the ocean floors are composed of, and then physically pushing down to a point where its weight is pushing to the moho, maybe, to really create like something that it gains traction and friction with to like lose material from. Upper 2 to 4 kilometers of the crust are low. Therefore, these data do not resolve the base of the volcanic edifice that forms. Suggest the base of the volcanic edifice is as a depth below sea level of about 10 kilometers, and therefore that up to about 8 kilometers of extrusive and intrusive volcanic material has been added to the top of the pre-existing Pacific Ocean crust and its formation in the late Cretaceous. Good sign. Not that that wasn't best fit. Yeah, I'm gonna go ahead and say that the evidence is still supportive of that this is a particle rolling through. Uh, Best fit between the observed seismic MOHO and the calculated MOHO based on a flexure model in which the driving load is defined by the present day bathymetry suggests an elastic thickness of 14 kilometers. Pre-existing oceanic crust thickness of 5.1. Driving load. Elastic thickness. There is an evidence of intrusive bodies in the flexed pre-existing oceanic crust beneath Swico and Jimu Goyas, which may have contributed to their excess subsidence. Ew. Not associated with as high a P wave velocity and density as other seamounts, such as those in the northern Louisville Ridge, which formed on younger seafloor than either of these. Younger being more hot, it's hotter, so it's more like fluid. It's more, as I wrote down here somewhere, heat is a lubricant, so it allows for like flow without resistance. So by it being on a newly forming ocean bed, it's still hotter than the pre-existing ocean bed that formed where this particle's rolling atop and like pushing into cooler material that then causes a like greater degree of its capacity to like grab on and hold chunks, whereas maybe like I mentioned in a previous video, maybe there's some sort of separation here where there's like a particle coming down this way. It hits the resistance of the current and bends off of it, but then breaks a segment down this way. That maybe just... It just doesn't make sense, though. That it connects here is crazy. This also looks very similar to Hawaii in terms of having a lot of, like, points from it. Whatever these things are, I don't think they're just straight up, I just don't think they're just straight up mapping remnants. I think they're like actually in the data. And Hawaii is kind of like a node, but then so is Tahiti. I've been certainly having thoughts that there's a relationship of Tahiti as well, and to this whole process even. Maybe the key is in this region. To make it make sense requires the key. I just don't know. Okay. So that's all I got for now, I guess. I'll be back. See y'all soon.